completing the square. Okay, this is so important to understand. You will be doing this for the rest of your mathematical life, basically. You know, whatever you will be reviewing this next year, the year after that, the year after that, the year after that. You just have to know this really well, backwards and forwards. The reason why completing the square is important is that it works for everything. Okay? Now, it doesn't mean you will use it for everything, because it's not always the easiest thing to use, but it works for everything. Now, what I have been doing so far is, and Nate too, we have been giving you tools. You've got a tool belt, right, of things. You know some things about factoring. You know how to factor out the greatest common factor. You know how to factor the difference of two squares. You know how to factor a quadratic trinomial where a is 1, meaning like x squared plus 8x plus 15. You know how to factor a quadratic trinomial where a is not 1, or a is 2, or 3, or 4. And you can either do the guess and check method and do like 24 tries until you find it, or you can use Gary's terrific trick, right? Both of those methods are important, and both of them you'll end up using at some point or other. Now, the only thing is, I have been very nice to you so far. Okay? The things that I have been doing for you is I've been giving you things that are factorable. Okay? And so the question is, if they're not factorable,
what to do? They're unsolvable.
With the methods and the tools that I've given you, what do you do? And it's challenging, right? So, mathematicians had to figure this out. These were the questions they came up with, and they said, well, what could I do? Now, before we even go into the process, let's look at the title for a second and ask ourselves, why the title? Why did they call it this? What is a perfect square? Anybody? Indeed.
It's when both the sides are the same length and they're right angles.
So if I had a square, right? Hopefully that's a square. Yes, you can see it on there. So and this was 4, and this was 4. What would be my area of that square?
4.
Everything inside. Area is base times height, right? Remember that? So it's 4 times 4 is 16.
It's 4 squared.
Now, yeah, 4 squared.
4 squared. She said 4 squared.
This is the most important lecture. Okay, but yes, how many more do you have?
If you can't spare them right now, I will go get some uniforms.
It would be great, because this is the lecture they don't want to miss. Trust me, it's really important. Where was I? So the area of this was 16, right? Now, what is cool about 16? 16, we're saying, is a perfect square, right? 16 is a perfect square. You guys agree with me with that, right? Why is a perfect square awesome?
Because you can square it.
You can square root it. You can always square root a perfect square. That is brilliant. Okay, you hear me? That is brilliant. All right? Now, what if my perfect square was x and x? What would be, my sides of my perfect square, what would be my area?
X squared.
X squared. Can I take the square root of that?
Yes.
Why? It's a perfect square, right? You can take a square root of anything that is a perfect square. All right? Now, what if I had this? What if I had a square like this? Never mind. Start over. What if I had this square, and let's say the sides were this, x minus 3 and x minus 3. What is my area? How would I find my area then? So it would be x minus 3 parentheses x minus 3. Am I right?
Yes.
And then I'd have to use what process to find?
Foil.
Foil, right? 2 binomials multiplied, use FOIL. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9.
my God.
And I can simplify this, right? So my final answer would be x squared minus 6x plus 9. This is what? This is a perfect square. We multiplied the same thing times itself, and we got this. This is a perfect square. So the cool thing is anything that's a perfect square, you can take a square root of, right?
Yes. Oh!
Right? This is really important. So anyways, that's my intro. Now we're going to talk about the logistics of how this works.
Hang on, Gary. Or you can erase the square first.
Don't erase that. Okay. So what is this? What is the square root of this? It's x minus 3, right? It's the number that we multiply times itself. Square root of this is x minus 3, right? You with me? Now, what's interesting, how could I write this without two sets of parentheses?
Just put it all in there and times them both by x minus 3.
How could I write this in a different way? Any different way? So you're saying this, right? I think this is what I think you're saying. X minus 3 parenthesis squared?
Yeah.
Yes. You guys agree with that?
Yeah.
So when I put the square root around this, over this, that's kind of confusing because I don't know, I'd have to figure it out, right? But look, what if I didn't multiply it out, but I left it like this? I could say the square root of this is just x minus 3, or I could say the square root of this is x minus 3. You guys with me?
Yep.
It's all the same thing. It's all the same thing. But it helps to have it more in these formats, right? This is the same thing as that. You guys all clear on that?
Yeah.
Okay. Awesome. Now we're ready to move forward. So, can I erase? No. No, you always say that right after I'm done. Okay. So, I'm going to take a problem that we can factor for now, okay? Remember I told you completing the square always works, right? I'm going to take a factorable trinomial that you guys know how to factor, and I'm going to show you this process. Sometimes it's helpful to use an equation that an expression or a problem that you already know how to factor because you can prove it. You can prove that it's right when you get the answer, below. So watch. Let's do. Let me think. I'll just make up one then. So we're going to do x squared plus 6x plus 8. Right? You guys agree with me? We could all factor that.
Yeah.
Factors of 8 that add up to 6, 2 times 4, right? So it'd be x plus 2 times x plus 4, right?
Yes.
Pretty straightforward.
Yeah.
All right, now we're going to use completing the square to see if we're right. See if we get the same answer, okay? So, completing the square. There is a number one rule. This is a important rule. Important rule. Very, very important, right? Right? Very important. A, what's my A? It's the number in front of my x squared, right? What is that number? 1. A must, underline the word must at least 10 times, equal 1. Okay? A must equal 1. And it's because of that rule that you won't always use completing the square. Because sometimes it will be hard to make that A 1. Right? But it always works. And you can do anything with completing the square. It just may not be easy. But these are going to be easy. What we're going to do now is easy. Do you need to take somebody? All right, conceptual people. Take conceptual people.
Okay, so can I have 3 conceptual people come with me? I can 3? Or okay.
Yeah, 3 or 4 out of 10.
Conceptual folks come with me right now.
Okay. Picture day. Okay. That's an important rule. When you're completing the square, you have to somehow imprint it into your brain that you have to always ask yourself, if they say solve this by completing the square, the first thing you should say is A equal to 1? Is A equal to 1? Is A equal to 1? Yes. Okay, so we can do it. We can begin. Okay.
But it's not equal to 1.
So actually, I have to do one more thing. Let's put it equals 0. Let's put equals 0. Put equals 0 in there. Okay? Now, when you're solving a completing the square problem, it has to you have to first have it start equaling 0, so that you're starting, because that's how you factor, right? That's how you've been taught to factor. At least I think, well, at least the conceptual group. But my group, we were going to cover that today.
Zeros after.
That if you were going to factor this, you would find the zeros. But when you are completing the square, that's what you're finding. You are finding the zeros when you complete the square. Okay? What are the zeros again?
They're the x-intercepts.
The x-intercepts, where the parabola crosses the x-axis, right? Where it's crossing. That's all we're trying to do, right? So, this is what you do. You decide that you are going to create a perfect square. Okay? Does that make sense?
Yeah.
We just went over the value of a perfect square, right? The perfect square is I can take a square root of something, right? That's so important, and you're going to see why it's so important. Because right now we have x squared, and I don't like x squared, but we're going to deal with that in a second. We're going to look at this, and we're going to say, I know that this part right here I can keep. But I want to change this to be, I want to choose a number there that will make this a perfect square. So what I got to do is I got to get rid of my c. My c, remember, that's my c. I got to get rid of it.
Do you always have to get rid of it?
Always have to get rid of it. And I'm going to, in place of that c, I'm going to leave a blank space. Okay? So what I'm going to do is I'm going to subtract 8. Because that's the only way, adding or subtracting is the only way to move something from one side of the equal side to the other. Only way. So I'm going to subtract 8, but if I do it to one side, I got to do it to the other. And I'm going to draw my line, and I'm going to have x squared plus 6x, and then I'm going to put a plus, and I'm going to have a space here, equals -8. Everybody with me so far?
Yep.
Okay. Now that I have that space, I get to create a perfect square.
Oh my god.
And there is a trick to this. To find this number, to find your c, I'll put it over here. To find perfect square c. This is what you do. 1 divide b by 2, and then 2 square that number. So you're going to see what I mean in just a second. Okay, so it says divide b by 2. What is half of 6?
3.
Right? You guys all with me? You're dividing 6 by 2.
Where does
6 divided by 2 is 3. So I'm gonna just for now I'm gonna write, is it a positive 3 or negative 3?
Positive.
It's really important that the signs are clear. If that was a negative 6, it would be negative 3. But that's positive 6, so it's a positive 3. Now, what is 3 squared?
9.
So that means I am going to, my c is going to be 3 squared, which is 9. Now notice it's plus 9, right?
Yeah.
What if it was negative 3? What's negative 3 squared?
Minus 9 still.
It's still plus 9.
Wait.
It's still, see, negative 3 squared is negative 3 times negative 3, right?
Oh.
So when you're completing the square, this last sign here is always positive. Is that clear? Always positive. There's never a negative there. Always positive, because whatever it is here, when you square it, it becomes positive. Right? Positive times positive is positive. Negative times negative is positive. Right? Yes.
How
So.
come you just get to like put in the number and you have to do it to the other side too?
Right. I can't. Now, I just added 9 to this side. Did I just destroy my equation?
Yes.
Right. So what do I have to do?
Add 9 to the other side.
I have to add 9 to the other side. So I'm going to put
How did
plus
you get
9.
9? I was trying to write down the other things.
Oh, so I followed this rule. I divided b by 2. So here's my b, which is positive 6.
Yeah.
6 divided by 2 is
3.
3. Now, I encourage you in the beginning to write what 6 divided by 2 is. It's 3, and circle it. I suggest that, and you'll see why in a second, okay? Just trust me, it's really valuable. All right, then you all understand now? So 3 squared is 9.
Yeah.
I added 9 to the left side, I have to add 9 to the right side. Otherwise, I no longer have an equation, right? So now, this is a perfect square. What would this be? What's factors of 9 that add to 6? 3 and 3, right? 3 times 3 is 9. 3 plus 3 is 6. So I could factor this as this. X plus 3 times x plus 3. You guys agree with me?
Yes.
Okay, equals, what is negative 1 plus 9?
Negative 8 is 1. You said negative 1 plus 9.
I mean,
It's
what
negative 8 plus 9.
What is negative
1.
8 plus 9?
1.
Right, it's 1, positive 1. Okay. Now, how did we say we could rewrite this?
X plus 3 squared.
X plus 3 squared, right? I could do x plus 3 squared. That's normally how you're going to write it. Now notice, remember I asked you to put this little number in a circle underneath it? Look what that is.
Whoa.
So by just putting that number there, you automatically know how to factor this. You don't have to go factors of 9 that add to 6, right?
Oh my
Because
goodness.
half of 6 is 3, that's the answer. So you just put, if that's a positive 3, you put x plus 3 in parentheses squared. If it's a negative 3, you do x minus 3 in parentheses squared. If you forget that, just go ahead and factor it. Factors of 9 that add up to 6, right? If you forget that. But by doing, just taking half of 6 and writing that number there, that's the number that's in your factored form. Yes?
Sorry, but where did the 9 come from?
9 is following this rule. Okay? So watch.
Oh,
I divide b by 2. 6 divided by 2 is 3. I write my 3 here because that's going to go here,
Yeah.
right? But 3 squared now, I square that number. 3 squared is 9,
Yeah. Okay,
right?
got it.
You got it? So this is really important, this little process. That's the whole way you find a perfect square. Question to Micah.
What do we do with the 1?
Okay, so wait, so we right now have this, right?
So now you
Did somebody else have a question?
square root
Emma, did
divide
you have a
it.
question?
Yeah. So like, is it always going to be x plus and then like whatever?
This will always be a plus. Is that what you mean?
No, like down there.
Down here.
Like,
It's, if this was a negative 3, this would be x minus 3.
but it's always going to be like x plus or minus.
Yes.
the-
X plus this or x minus this, right? Yes, Sal.
Square rootify the bottom.
What?
Square rootify the bottom.
Say what?
That part.
Square root it.
Ah, what do we have? We have a perfect square in this side, right?
Perfect square.
You guys, we have a perfect square!
Yay!
This is amazing! And you know what? We have a perfect square over here too. Now, it's not really essential. This is, guys, listen, really important. This is really important. It's not essential that this is a perfect square. It's essential that this is a perfect square. Eventually, we're gonna do another problem where this is not a perfect square, okay? Here we go. If this is a perfect square, we can take the square root of it. And the square root, all it does is it cancels out the square. But if I do it to one side, I got to do it to the other. You with me? So what is the square root of x plus 3 squared?
X plus 3.
X plus 3.
Whoa.
We now have gotten rid of x squared. That is huge. We only have an x. It's going to be so easy to solve for x now. So we've got x plus 3 is equal to, now this is the one big tricky part.
Positive or negative 1.
This is the big tricky part. Normally you'd think, well, the square root of 1 is 1. 1 times 1 is 1,
Plus or
right?
negative 1.
But it's going to be plus or minus 1.
Oh my god.
That's the big thing you have to understand. Positive 1 times positive 1 is equal to 1, right? But negative 1 times negative 1 is also equal to 1. So this means you're going to get two different answers. Because this means that x plus 3 is either equal to positive 1 or, remember that word or? x plus 3 is equal to negative 1. So I'm going to just write that out. X plus 3 is equal to 1, or x plus 3 is equal to negative 1. Okay? So, so now I'm going to subtract. What am I doing wrong here? Subtract 3. Subtract. I did something
So we
wrong.
are finding the zero.
Wait, what am I doing?
No, you did that right. Yeah, you can do it.
What am I doing? Oh, wait. Oh, yeah, you're right. I'm sorry. I forgot. I was thinking, I see. No, we did this right. So subtract 3. So we've got x is equal to negative 2. Am I right? And then here we're going to subtract 3, subtract 3. We have x is equal to negative 4, right? Okay. Those are my zeros. Now, if I had factored this, I'm going to use a different color just to show you. If I had factored this immediately, the way I know how to factor it, I would have this. Factors of 8 that add to 6.
2 and 4.
2 and 4. So it'd be x plus 2 times x plus 4 equals 0.
Negative 2 and negative 4.
So then I'd say x plus 2 is equal to 0, which means x is negative 2. X is negative 2. Right? You with me, Clayton? X plus 4 equals 0, which means subtract 4, x is negative 4. I just found the zeros using completing the
But
square.
it was
What is
harder
the
than regular.
purpose of
On this particular problem.
In this particular problem, that would have been much faster, right?
Yep.
But I use this problem to just because it's so easy to use a problem that we already know how to factor, because then we can check to see if we did everything right, right? If we can prove we did it right.
what purpose does this serve?
That is a great question, Nathan. That's the exact question I was hoping you in particular would ask. What purpose? Yes. What purpose does this serve? All right. Now I am going to give you a problem that is not factorable.
Oh my god.
Okay?
Yay.
Here we go. Can I erase?
No.
It's okay. Can I erase up above this part? I'm going to erase just the problem because I'm going to write a new problem. That was x squared. We're going to do 2 more problems, and we're going to do these a little faster now, okay? Now that you know the process. So here's the next one. Here's number 2. We're going to do x squared. That other one was plus 6x, and it was plus 8, right? Okay, I'm going to do plus 7. All right? Equals 0, right? Equals 0. All right, and so I'm going to ask myself, okay, so what are factors of 7 that add to 6? Well, there's 7 times 1, but 7 plus 1 is 8. Shoot, right? So it doesn't work. There's no factor of 7 that adds to 6. You see what I'm saying? Doesn't work. So this is what I'm going to do. I am going to complete the square. Right? I am going to, I first see, is my a equal to 1?
Yes.
Yes. So I'm going to subtract 7. Subtract 7. Subtract 7. And I'm going to erase all this. Can I erase this now?
Yeah.
Okay, so help me with this. So I've got x squared plus 6x plus space is equal to negative 7. And if you want, it's not a bad idea to say plus space if you get in that habit, because then you won't forget to add something to both sides. Okay? So what's half of 6?
3.
I'm using this rule now. These two, that thing. So half of 6 is 3. I'm going to put a positive 3 there. And I've got 3 squared is 9. So I'm going to add 9 to this side. I'm going to add 9 to this side.
What if B isn't 6? Oh, well then you just do the same.
Then, yeah, if B was 4, it would be 2 here.
What
What
if
if
B
it's
is
B
odd
was
number?
8, it would be 4 here. B
Yeah,
was
what if-
16, it would be 8 here.
What if B is like 7?
It would be
5.
7 halves,
7.
or 3.5, right? Right?
What if
That's
it
where
was
they get a little
negative?
harder, is when your B is an odd number, okay?
weird little.
So now I could factor this, factors of 9 that add to 3, or I happen to know it's going to be x plus 3 squared, right? Because that's a plus 3. So I know it's going to be x plus 3 in parentheses squared. You with me? I know it's going to be that because of this. Half of that is this, and I know that's going to be here. So I'm not going to have to figure it all out. Equals, what's that, 2?
2.
2. All right, perfect square, I can take the square root. And the square root and the square cross each other out. So all I have left is x plus 3. I have to take the square root of this side. Equals, in this case, we have plus or minus. I don't know what the square root of 2 is. It goes on forever. And I don't want to write forever. So the best way to do it is leave it as the square root of 2. So I'm going to do this.
Oh my god.
So x plus 3 equals plus or minus the square root of 2.
Why is it plus or minus?
Plus or minus because remember plus or minus, remember when it was a square root of 1? We figured we could get it by either doing positive 1 times positive 1 equals that, or negative 1 times negative 1 equals that. Well, the same thing is true of this. Positive square root of 2 times the positive square root of 2 is the square root of 2.
So does that apply to every square root?
Yeah. So from now on, whenever you're doing completing the square, when you put the square root around this right side, you've got to put a plus or minus sign there. Always. That's really important. Got it? Make sense? Okay. So now these are actually, in a way, easier than the ones that solve in a whole way. Because in the whole way, you've got to, like the previous problem, I had to split it up into 2 problems, right? I said x plus 3 equals positive 1 or x plus 3 equals negative 1. But in this case,
This is your.
I can't really do much. So I'm going to just subtract 3 and subtract 3 all at once. And I'm going to say x is equal to negative 3, right, plus or minus
Square root 2.
the square root of 2. And that's my answer.
Oh god.
Now if I had to graph it, though, I'd get out my little calculator and I'd say, okay, square root of 2 is 1 point whatever, right?
1.2.
And then I would add it to 3 and I would subtract it from I would add it to negative 3 and I would subtract it from negative 3 and I'd get numbers that I could find on a graph, right, on my x-axis. But most of the time you don't need that, so you can just leave it in this form. So that would be my answer. I know that I'm confusing some of you, and that's fine. Don't worry about it, because you will practice them and we will practice them in class and stuff like that. So that's that. Can I erase?
Yes, I understand.
Okay, now we're going to do one more. That's harder. So you guys can see it, how it works in more well, it's not going to be the hardest kind because I can't stand doing this. No, shh, don't tell anybody I said that. Sorry, I have to find one. Okay, so sure.
Are we
So
doing
this
ones that are on
one,
the
this
homework?
one. Oh wait, but that
Does
hang
this
on.
one have like a larger A? Like 7 billion?
These are not good examples. Hang on, wait. Okay, that would work. Okay, well, okay, this is going to be a hard one. Okay, here's number 3. I've got 3x squared.
Called it.
Hang on a second, I just got to be sure this is going to work. Yeah. Okay, plus 20x plus 36 equals 4.
Why?
But it doesn't equal 1.
What?
A doesn't equal 1.
It's supposed to equal 0, right?
No. 1.
Oh, yeah, the equation is.
Right, the equation is supposed to equal 0.
So
But
minus 4.
But really, well, let's just think about it for a second. So I could subtract 4, and then I have 32 here, right? Right? If I subtracted 4. And maybe that's the easier way to do it. But I don't technically need to do that because I know I'm going to be moving this over, right?
Yeah.
Right? So in a way, and so it's not going to be equaling 0 when I move it over. So I could just move it over right now. Does everybody understand that?
Yeah.
Yeah.
I could just move this over and make it 32 and then subtract 32 from both sides. But that's 2 steps when I'm...
X is equal to 1.
What?
X isn't equal to 1.
You're right. X is not equal to... Oh, shoot, that's right. I'm not supposed to do this one. Oh, I don't want to do that one because that's going to be too hard.
Nice, Gary.
Sorry, I wasn't thinking. All right, now I remember. Hang on, sorry. Cross that out. That's an example of one that would be hard. I would not use completing the square for that one because 20 divided by 3 is a fraction, and I don't want to have to do that, right? Sorry, I wasn't thinking. This is what happens when I do a lecture impromptu, and I don't, it's like I didn't have time to even plan it, so I usually have my problems ready. So hang on, I was thinking I cancel. Okay, here we go. Let's try this one. 2x squared plus 12x plus 10 equals 0. Okay? So
X is equal to 1, that would be there.
So x is not equal to 1. So we have
A
to
is
make,
A.
I mean A. A is not equal to 1, so we have to make A equal to 1. How do I do that, Liam?
Divide.
Sorry.
Who said that? Okay, what?
Divide by 2.
Divide everything by 2. Everything
Oh.
in the entire equation.
But
So I
that
go
would
like
be
this.
catastrophic.
Divide by 2. Divide by 2.
Couldn't you just put
Divide by
parentheses
2.
around the entire
Divide by
thing
2. What?
and- Oh, never mind.
I'm trying to get rid of the 2, right? And the beauty of it being equal to 0 is I will get rid of the 2 because 0 divided by 2 is 0. So watch this. Those cross out. So I have x squared plus 2 goes into 12 6 times, so I have 6x. Oh, we got a 6x again. Jeez. I didn't mean to do that. But anyways,
Change
Plus
it to like
5.
14.
equals 0, right? But that's okay. You got the idea. If that was an 8x, we'd still know how to do it, right? Half of 8 is 4. I put a circle around my 4. If it was negative 10, half of that would be negative 5, right? I know what to do there. But we still got a 6 here. That's okay. So now I've got a perfect, my A is 1, and it's a trinomial, and it equals 0. I'm going to first move this over. I'm going to subtract 5. Subtract 5. So now I have x squared plus 6x plus space equals negative 5 plus space. Right? Half of 6 is 3, so I'm going to put my 3 there.
9 again.
And I'm going to do x plus 3 in parentheses squared is equal to, oh wait, okay. Oh, actually, I'm jumping. What's 3 squared? 9 again. Jeez, we keep adding 9.
Yeah, I know.
That's what happens when I do my impromptu lectures. But anyways, that's okay. Equals 4.
This one was factorable.
This one is factorable, right. So what do I do here? Square root. That gets rid of my square and my square root. Square root, I've got x plus 3 is equal to plus or minus 2.
Dose.
Right? So that means x plus 3 is either equal to positive 2 or x plus 3 is equal to negative 2. So I'm going to write that. X plus 3 is equal to positive 2 or x plus 3 is equal to negative 2. Okay? Subtract 3, x is equal to negative 1. Subtract 3, x is equal to negative 5. So those are my zeros. X minus 1, x is equal to negative 1, or x is equal to negative 5.
So we always find the zeros?
That's what you're finding when you're using completing the square.
Alright.
Again, completing the square works for everything
Absolutely.
as long as you make a equal to 1. But the previous problem that I almost did, that would have been a really hard one to use completing the square for. Because I would have had to have factors of something that added to
Everything would be like 1/2.
20/3, right? I wouldn't
Like, oh,
really want to do that. That's not my preference, right? So that's completing the square. Does that make sense? Did Nate give me copies? Nate? Is Nate here?
No.
Oh wait, here they are. Okay, sorry. He did. All right, so completing the square, I think.
Coffee.
Now sometimes, I just want to clarify. Sometimes it will not say it. Sometimes you'll see it like this. Sometimes you'll see a problem like this. Like if you saw like x squared plus 8x equals negative 4. Right?
Still,
It's okay. You just rewrite it so there's a space here. You've already got your stuff over there, right, out of your way. So you're ready to begin plus space equals negative 4 plus space. You're ready to go ahead and do your,
Did it for you.
complete your square. They did it for you.
And
So
then
don't
just
let that
divide
throw
8 by
you
2
off.
and then square that, right?
Yeah, so then, half of this would be 4. 4 squared is 16, so you're adding 16 to both sides, right?
Oh!
And then x plus 4 parentheses squared is equal to whatever, 12. All right, conceptual group. with the regular group, you may need
Large
to.
gray calluses on your iris.
With the regular group, guys, I'd like you to use a separate piece of paper and staple it to this, just because otherwise it's going to be too confusing.
Guys, have you stopped the lecture?
Oh, I didn't stop the lecture.
Oh.
Anybody want to? No. I guess I should.
Delete the whole lecture.
Let me stop this.